Well, I thought I'd put just a little bit of a video together because I haven't put much on YouTube for quite some time. Just put my little speeder project on yesterday. So this is another thing I've been working on for quite a while. I got this Baker Heller Ayler windmill. I believe it's around I think I've been told it's around a 1930s era, 35, 37. Pretty bad shape when I got it here. I got it off a friend of mine who got it off another guy. Everybody had the intent to put it up, but I'm making a little headway on it. I got the top unit pretty much rebuilt. This is all brand new here. The old one, if I can dig it out here without confusing everybody too badly. Here's the old one, and you can see it has been rebuilt once. You can see down the bottom there where it's all was worn through and somebody put a brass bushing in there. And then the brass bushing is just about worn big egg shaped anyway. So I replaced all that with a bunch of nice roller bearings. So now inside of here you got double roller bearings, and you come back to the back here where the tail's going to go. There's a double set of roller bearings here, and there's a thrust bearing inside here. So, and I'll take the lid off and I'll show you what that looks like. Of course, these are redone. I got some stainless steel screws here. I have to redo this yet here. This has all been rebored, line bored out. You can see I got some nice brass bushings in there. I'm going to take this big Allen bolt out and put that back in stainless steel. And this got some nice little water jet stainless steel brackets here in the back of each one of these blades. So they bolt onto here, they rivet onto the blade. Then on the other end of the blade here, on this side, you got another rivet here. That should keep these blades from sliding out of this mount, because they're tapered. They're bigger here and they're smaller as they go here, so they can't fly out as this thing spins. So I will get the person's name off of Facebook. He does windmill restoration, has a lot of supplies. I'm going to get his name on here and make sure he gets credit. That was his idea to do those stainless steel tabs, and he sells a mounting bracket. This whole bracket brand new. In fact, all of this brand new if you need it, but he sells this bracket with that modification, so you have a ability to put a stainless steel bolt through there. So these blades I made myself, although this fellow I'm speaking of on Facebook windmill restoration page, he will sell you all these blades too. But these blades I made them all. They're all out of aluminum, and I made a progressive die to kind of stamp them in a press manually one at a time to get the right shape of them. So we got her in pretty good shape. Spins beautifully, smooth now. Beautiful, nice and smooth. Love it. Oh, feel that air. It's a hot day in here today too. So I'll get some video of the inside. Here's the tail. Hard to see here, but I did put new tips on the top of the tail there. Added a bracket here in the middle. Added this bracket. Added an additional bracket up here. You can see it had been repaired once already by someone else. They did a really nice job on it. Put that nice crimped edge on it. So I put new tail tips, used old school rivets, and then I doubled them down with newer stainless pop rivets in there too. So I'm going to get the graphics on the tail yet, but that'll be another future project. And I do have the 40-foot tower that it goes on, and I intend to make a hinge mount for that and put that all up together. I got some of the old windmill parts down there, so it's not going to be a pumper anymore. It's just going to be a spinner, since I don't really need a water pumping windmill. So, show you, here's what we had left of one of the old blades. I got some other parts here, using a hand crank for the furl the tail, guide stuff here, more guide rod. This is the top bearing here. And we got new stainless steel balls we're going to put in for that. That's what's left of the old spring, but we got a new modern spring coming for that. So, all right. that's going to be it for now. Until I get the top off, I'll give you some more video. All right, here we are at the windmill. I got the top cover taken off just to show you what's inside here. Obviously, I've taken all the pumping mechanism out. This is going to be set up just as a spinner. No real need to have it pumping water, and it's not placed over top of a well here. So just wanted to show you what I ended up doing since I put this new piece here, the shaft, this new front nose piece. There's a bearing up in here, and then you can see back in here, if I can get you, there's a bearing. That new front piece comes all the way, that nose piece comes all the way in here. So there's a bearing clear back here, and then there's a thrust bearing right behind this collar. And of course that shaft goes clear through to the back. And I have another thrust bearing right up against the casting. If I can do this with my finger, see what I'm doing here. Oh, finger's in the wrong spot. Yeah, there's a thrust bearing right in between there, another collar, and then of course back here, I have another set of bearings back here. So it's well supported. And of course, grease fitting in between the bearings on both sides. Same up here. And then I got, the seals taken out of the bearings on the inside faces so you can pump grease in and it'll grease the bearings. Of course, this guy here, we got that's going to be for the cable that furls the tail, and it's a stainless steel screw there. Just want to give you a look at the inside of this thing. So there you go. Moves nice and free. And it was, like I say, it was all line bored out. I line bored it straight through, so everything's all nice and in line and square. So it should make a pretty good job of it. But, okay. Here's some of the flat blade blanks that I had that I ended up making them out of. There's a few stacked here extra. But that's how they started out. Just flat, sheared, square on one edge, tapered on the other. You can see this here. Spin it around here. Yeah. This edge is at a 90 here. Same down here. This edge is at a 90. And then this edge is, of course, tapered out. And I'll show you the die I used to put the bend in. This was the die I built to form those different blades. That's the top half there. That's the bottom half there. And what this does is this goes on top like that. That's what forms the pieces like that. There you go. So that goes on there. And what I did was I drew the whole thing up in CAD, what the blades were, the curve, best I could get from the old blade that I had. And since I didn't really have any way of machining this whole thing in one big shape, I took the CAD profile and I split it into 3/4 inch sections, and I made a little drawing for each one. So I made each radius in each 3/4 inch section of wood, then bolted all the pieces of wood together to get my overall die in order to, and of course I subtracted the blade out of the die so that when they're together with the blade in there, that gives the shape. So now I just put this in a hydraulic press with the piece of sheet metal in there, pressed it down, and gave me the shape I wanted. So it worked out pretty good. Okay, getting ready to rivet on a new section of tail on the Baker windmill. I believe this thing was made in 1920s. I've been messing around with it off and on for a couple of years, but maybe this year will be the year it goes up. Windmill vanes, masked tips are all cleaned up, ready for paint. It actually looks kind of cool with the blue on there. I was going to do them red. Almost makes me want to go red with a blue inner stripe, but well, we'll see. It's supposed to be red, so. I got all the blade tips primed with self-etching primer. So we're just going to let it dry for a couple hours, and we're going to paint all them blade tips red. It's going to look really spiffy now. Okay. Well, there it is. Got all the tips painted red. Looking pretty good. Yeah, looking pretty good. That's cool. That's an 8-foot diameter fan.